everyone and welcome to e-sipnayan. So for this video, I'm going to be talking about circles. But of course, before anything else, please don't forget to like and subscribe to e-sipnayan so that you'll be updated with our new videos. By the end of this discussion, hopefully you'll be able to identify the center of the circle, solve for the radius of the circle, as well as construct a standard form equation of a circle given the center and the radius. Now let's start with the following terms to remember. A circle is a set of all points equidistant to a fixed point we call a center. Now for the variable of the center, we can use the symbol c. Now for the radius, our radius is the distance from any point on the circle to the center. And we can use the symbol r as our variable for the radius. So this is an example for radius. So a radius can also be described as a segment where one of the endpoints is the center while the other endpoint is at the outline of the circle. As for the equation of a circle, its standard form of equation is the quantity of x minus h squared plus the quantity of y minus k squared is equal to r squared. Now, h and k are what we call the coordinates of the center. And r is, of course, the radius. Now, if you want to identify the center of the circle, we must look for h and k. So, from the standard form of equation, h and k is where h is the x coordinate and k is the y coordinate of the center. Now, given that this is the standard form and we can see that this is negative h and while here we have negative k, we just need to reverse the sign to get the center of the circle. So for example, we have the following equations. We have the quantity of x minus 6 squared plus y minus 4 squared is equal to 9. So if we are to identify this center, where here we have negative 6 and negative 4, we just need to reverse the sign, so we can assume that the coordinate is 6, 4. For this equation, we have the quantity of x minus 3 squared plus y minus 1 squared is equal to 16. So we have negative 3 and negative 1. Then reversing the sign, the center is 3, 1. As for this equation, we have negative 1 and positive 5. Then reversing the sign of negative 1, we have 1. Reversing the sign of positive 5, we have negative 5. So the center is 1, negative 5. For this equation, we have positive 2 and we have negative 2 here. So we can say that the x coordinate is negative 2 while the y coordinate is positive 2. And lastly, we have here the quantity of y plus 1 squared plus the quantity of x plus 7 squared is equal to 5. Now, looking here, the first variable in this equation is y. Don't be fooled because reversing the sign of positive 1 is negative 1 and negative 1 is the y coordinate, while the x coordinate is negative 7. So our coordinate for the center is negative 7, negative 1. Now, what are the coordinates of the center if the standard form given is x squared plus y squared is equal to 1? What do you think can be the center of the circle in this equation? I'll give you a second to think about this. Now, if your answer is 0, 0, then you are correct. And of course, the radius is 1. So this is what we call the unit circle, where it means that the center is exactly at the origin of the Cartesian plane and the radius is equal to 1. So this is an illustration of the previous equation that we have earlier, where the origin is at 0, 0 and the distance from the center to a point is 1 or 1 unit. So whatever radius that we can see here, the radius will always be equal to 1. So without any hints of what hk may be, let us try these examples. We have x squared plus y squared is equal to 9. So of course, even though we don't see any hk, we know that the coordinate of the center is 0, 0. As for this second equation, we have x squared plus y squared is equal to 16. If you've guessed 0, 0, then you are also correct. For our next equation, we have x squared plus the quantity of y plus 5 squared is equal to 36. So our x coordinate, as you can see, our x coordinate is 0, while the opposite of positive 5 is negative 5, then our center is 0, negative 5. And lastly, we have the quantity of x plus 2 squared plus y squared is equal to 25. Knowing that this number here is positive 2, we reverse the sign, then this would be negative 2. And as for our y coordinate, even though that we cannot see any constant here, we know that the y coordinate is 0. So therefore, the center of the circle is negative 2, 0. So both equations, such as this one, can be standard equations of a circle. So we have here a second equation, x squared plus y squared is equal to r squared, where our center is at the origin of the Cartesian plane. Now that we know how to identify the center of the circle, let us try identifying the radius of the circle. So from the standard equation of the circle, we can see that in the other side of the equation, we have r squared. Now, it is easy to identify the radius just by getting the square root of r squared. Now, let us try to identify the radius given some of this equation. So for number 1, we have our r squared, which we can identify as 9. Now, knowing that this is r squared, we simply get the square root of 9, which is 3. So the radius is 3. Now, for the second equation, our r squared is 16. Now, getting the square root of 16, r is equal to 4. Now, our r squared in this equation is 4. Now, getting the square root of 4 is 2. So, the radius is 2. So, in the other side of the equation, the constant is 25, or the r squared is 25. Then, getting the square root of 25, our radius is equal to 5. And lastly, we have an r squared of 5, and getting the square root of 5, so we can either simplify this and get a decimal equivalent, or we can just say that the radius is square root of 5. So the decimal equivalent of square root of 5 is 2.24. So constructing a standard form is easy given the center and the radius. So knowing the format of a standard form will be very helpful. All we have to do is to substitute the coordinates of the center, but please keep in mind that it should be in reverse signs when we are going to be substituting it with the standard equation. As for the radius, all we need to do is to get the square of the radius for it to be in standard form. So for example, we have the following center and radius. Keep in mind that we substitute hk, but of course in reverse sign, and we substitute the square of the r. So in this case, we substitute 0, 0. So we have the quantity of x minus 0 square plus y minus 0 square is equal to 3 squared. Now we have the quantity of x minus 0 squared plus the quantity of y minus 0 squared is equal to 3 squared. Now the next thing to do is to simply simplify this equation to get the standard form of equation of the following center and radius. So therefore we have x squared plus y squared is equal to 9. So this is definitely the standard form of equation with the following center and radius. As for this one, again, don't forget to reverse the sign of the center coordinates and as well as squaring the radius. So substituting this to the standard form, we have quantity of x minus 3 squared plus the quantity of y minus 1 squared is equal to 2 squared. As you can notice, we reverse the sign. So here in the x coordinate, we have 3. And of course, here we have negative 3 as well as the positive 1. Here we have the negative 1. Now simplifying this equation, we have quantity x minus 3 squared plus the quantity of y minus 1 squared is equal to 4. for this example, we have a center at 4, 8, and a radius at 7. Substituting this, we have the quantity of x minus 4 squared plus y minus 8 squared is equal to 7 squared. Now simplifying, especially the radius, 7 squared is 49. Now for our fourth example, we have a center at -1, 5, and a radius at 4. So we have here quantity of x plus 1 squared plus y minus 5 squared is equal to 4 squared. Simplifying 4 squared, we have 16. So our final answer for this standard form is quantity of x plus 1 squared plus quantity of y minus 5 squared is equal to 16. Lastly, what if our center is at 0, -10, and our radius is equal to 10? So we have x minus 0 squared plus the quantity of y plus 10 squared is equal to 10 squared. Now simplifying this equation, we have x squared plus the quantity of y plus 10 squared is equal to 100. Now let's try graphing these circles. But before that, let us recall this one. This is what we call a Cartesian plane, and it has 4 quadrants. So this is quadrant 1, this is 2, 3, and 4. Now each quadrant has a specified sign of coordinates. So here in quadrant 1, we know that both x and y coordinates are positive. While here at quadrant 2, in this side of the line, we have the negative x coordinates and a positive y coordinate. So in quadrant 3, we have both the x and y coordinates as negative coordinates. And lastly, for quadrant 4, we have positive. In quadrant 4, we have positive x and negative y. So to graph a circle, all we need to know is the center and of course the radius. So our center is at hk, our radius is the square root of r squared. Now, of course, also the endpoints, there should be a minimum of 4 endpoints for us to construct the circle. So the endpoints can be identified as adding or subtracting the radius in both the h and the k for us to identify the 4 endpoints. So let's try graphing a circle. So number 1, we have to identify the coordinate of the center and then solve for the value of the radius so that we can identify the 4 points or the 4 endpoints that we need to construct. So we have here the equation, the quantity of x minus 3 squared plus y plus 2 squared is equal to 9. So knowing that this is the standard form of equation and we can easily pinpoint what is hk and the radius, our center will be at 3, -2. So since the x-coordinate is positive and the y-coordinate is negative, we can know that the point is at the 4th quadrant. Plotting this is 3 and this is -2. So here we have the center of the circle. Now, getting the radius is the second step. Now we know that this is 9. Now getting the square root of 9, we have 3. So knowing that this is the center and the radius is 3, we can count 3 units from the left, from the right, and of course up and down as well. So here we have 1, 2, 3. So an endpoint may be 6, -2. And from the center, let us count again 3 units from the left. 1, 2, 3. Here we have 0, -2. From the center, we can count upwards 3 units. 1, 2, and 3. So in this case, the coordinate is 3, 1. Now from the center, counting downwards 1, 2, and 3, we can say that the 4th endpoint is at 3, -5. Now given this endpoints and the circle, we can definitely construct the circle. Now let's try this one as well. So the first step again is to identify the center of the circle. Now knowing this one, the x-coordinate is -1, the y-coordinate is +4, so our center is at -1, 4. Now plotting this one, since our x-coordinate is negative and our y-coordinate is positive, then we can say that the center is at the 2nd quadrant. So this is negative 1 and this is 4. Now, the second step is to solve for the radius. So in this equation, we have 16 as our r squared. Now, getting the square root of 16, we have 4. Now, counting 4 units to the right, we have 1, 2, 3, and 4. So our first endpoint is at 3, 4. So for our second endpoint, we count from the center 4 units to the left. We have 1, 2, 3, and 4. So our second endpoint is at negative 5, 4. So from the center, we can count upwards 1, 2, 3, and 4. So our third endpoint is at negative 1, 8. And lastly, counting downwards from the center, 1, 2, 3, and 4, we can say that the fourth endpoint is at negative 1, 0. So with the following points that we know, we can construct a circle. For our last example, we have x squared plus y squared is equal to 1. Now the center is at the origin, so we have it here. Knowing the radius is 1, the square root of 1 is 1, so the radius is 1. Counting from the center to the right, we have the first endpoint at 1, 0. The second endpoint at negative 1, 0. Third endpoint at 0, 1. And of course, the fourth endpoint at 0, negative 1. So this concludes our discussion regarding the conic section of circles, and I hope that you learned a lot and that I hope that you can continue watching some of our videos. Thank you for watching. This has been e-sipnayan.